equivalent calculation of number of electron, proton and neutron. This is element X, which is said as Zxa, where Z is atomic number, which is equal to number of protons, that is equal to number of electrons. A here represents mass number, which is equal to number of protons plus number of neutrons. To find the number of neutrons, subtract Z from A. Calculation of charge. We think that magnitude of charge on an O2 minus charge will be plus 2, but it is wrong. Actually, magnitude of charge is represented by 2 into 1 per 6 into 10 to the minus 19 coulomb. Faraday is the charge on 1 mole of a substance, equivalent with the number of parts of by mass of a compound or element which combines with which displaces 1 part of mass of hydrogen and 8 parts of mass by mass of oxygen, 35.5 parts by mass of chlorine is called equivalent weight. Equivalent mass of an element equals to atomic weight by valency. If y minus x gram of oxygen reacts with x gram of metal to give y gram of metal oxide, then 8 gram of oxygen will give y upon y minus x into 8 gram of metal. It is just unitary method. In general, equivalent mass of substance is equal to molar mass by n factor. N factor differs for every single thing, every single chemical, that is acids, bases and salts. For acids, usually the N factor is number of hydrogen present in it, but there are exceptions such as H3PO4 has 3. Some exceptions are other. For example, this is a normal acid, H3PO4 orthophosphoric acid. Here 3 hydrogen are present, so N factor is 3. Similarly, in crystalline oxalic acid we have 2Ha, so is the N factor, which is equal to. Now there are 4 exceptional cases which does not fit into this. These are H3PO3, H3PO2, H3BO3 and acetic acid, orthophosphorus, hypophosphorus, orthoboric and acetic acid. These have NF2, orthophosphorus has Na2. However, there are 3 hydrogens. Similarly, hypophosphorus acid had NF1, orthoboric acid has N factor 1, and acetic acid also has N factor 1. However, there are 3 and 1, 4. So this is all about the